Hello everyone. So let's talk about today's Geeks for Geeks problem of the day. So let's see what is given in a problem statement, and after that, let's try to apply some intuition on this problem statement. Okay. So let's see. We have given in two integer values n and r. The task is to find the binomial coefficient nCr. Okay. Now they define what is the nCr. They define the formula of nCr. We just have to solve, and they give us some two important notes. Okay. So we already discussed about the nCr. We know how we calculate the nCr. We calculate the nCr. nCr is equal to n factorial upon n minus r factorial upon r factorial. Okay, so we have given an example test case. Let's try to solve this example. So we have given 5cr. Okay, so they give us a 5cr. So how we will solve this 5cr? So this is 5 factorial upon 5 minus 2 factorial upon 2 factorial. Okay, now let's try to solve this problem. 5 into 3 into 2 factorial 2. Okay, 5 into 3 into 2. Let's see. This is an 5 minus 3 factorial. Okay, so this is 3 factorial into 2 factorial. So can I write this as 5 into 4 into 3 factorial? Yes, we can write this as. So this 3 will get cancelled and we left with the 5 into 4 upon 2 factorial, which is nothing but 2. Okay, let's see. We can solve this 2 into 2 ones are 2, 2 2s are 4. Okay, 5 into 10. So the NCR 5CR is equal to 10. This is the answer. Now we have to solve this problem. They mentioned if the R is a greater than N, then return the 0. For this test case, this will satisfy the condition. And if 5C 0 is always 1. Okay. Now we know this all things. Let's try to see how we'll solve this problem. So 2 or 3 days ago, we solved the one famous problem, which is a Pascal triangle. Using that Pascal triangle, we'll try to solve this problem as well. Now let's see how we'll relate these two problems with each others. Okay, so this is nothing but what we say. As if you know, if you don't know this problem, I'll mention the link of the problem in a description. So do watch that problem as well if you want to make a clear understanding of this problem. Okay, so let's see. This is term showing the 0C0. Then after that 1C0 and 1C1. Okay. Similarly, I'll just make a beautiful design so you'll understand very well. So this is nothing but a 1C0, sorry, 0C0. After that 1C0 and 1C1. Okay. Now next term is 2C0, 2C1 and 2C2. Okay. These two are okay. Now 3C0, 3C1, 3C2 and 3C3 and so on. Okay. It will go to so on. Or I'll just made it a little bit. Okay. Now this is an 4C0, 4C1, 4C2, 4C3, 4C4. Okay. And the 5C0, 5C1, 5C2, 5C3, 5C4 and 5C5. Okay. This is all the term of a Pascal triangle which is displaying a binomial coefficient. Okay. Now if you just calculate this, you will get this as an output. If you calculate all of this, you will get this as an output. We discussed this one that previous video. Okay, now what I am saying, if you are looking the 5C2, what is the 5C2 here? This is an 10. Okay, and if you clearly observe this triangle, if you already solve this problem, what you are seeing, you're seeing the previous two numbers, a previous row, the two number, addition of the two numbers, it's coming this term. Okay, now let's see the 1. Okay, the 1 plus 1 the 2, then 1 plus 2 is a 3 and 2 plus 1 is a 3. Okay, this is going same as this. 1 plus 3 is a 4, 3 plus 3 is a 6, 3 plus 1 is a 5. Okay, now you are looking this is a simple clear pattern. Okay, if you are looking this, 1 plus 5 is a 5, 1 plus 4 is a 5, 4 plus 6 is a 10. Okay, 6 plus 4 is a 10, then 4 plus 1 is a 5 and 1. Okay, now if and so on, this will continue with this, the 5 plus 6 is a 15. If you are try to extend this, you will get similar result for all of this. So can I say if you are looking clearly for this example, if I say I want to say the 5C2, if I have to calculate the 5C2, can I say this is the addition of the 4C1 and 4C2? Can I say this is an addition of the 4C1 and 4C2? Can I say? Now if I look clearly, if I have to calculate a 4C1, this means this is the 4C1. Can I say 3C0 and 3C1 addition of 4C1? So can I say 3C0 and 3C1 is the addition of this? Okay. If I go to calculate the 3C0, I know that 3C0 is a 1. Okay. If I have to go to calculate the 3C1, can I say This is also the 1. This is also 3. Okay. Now what I am saying, if the 3C0, if 1. So if I just try to do this, if I just do, which is 2C0 and 2C1. Can I say this? Let's try to. Okay, this is an 2C0 and this is a 2C1. Okay, and the addition of this is a 3. Okay, now this is, and this is a 3C1. So if I am looking at something which is, I can say this is an nCr. So the addition of n minus 1 cr minus 1 plus n minus 1 cr. I can see this. I can look this formula from here. Okay, I can say this. So if I try to build and something recursive formula, if I try to build some recursion formula, let's see, the first approach is the recursive approach. By looking this observation, I found out some recursion approach. So if I just say that f of n and r, okay, the function n or r is the addition of f of n minus 1 and r minus 1 plus f of n minus 1 and r. Can I say this? Yeah, we can say. Why I'm saying this? Because I'm looking, if you look the Pascal triangle clearly, if you look this Pascal triangle clearly, that is coming, the nCr, that is 5C2, is the addition of 4C1 and a 4C2. We are clearly looking. If you see this Pascal triangle, the addition of previous two numbers, not clearly, but previous two notation, like which I am saying, the addition of n minus 1 cr minus 1 plus n minus 1 cr. This is the next term of nCr, okay, is equal to nCr. I am looking this, I am seeing this, that nCr is equal to n minus 1 cr minus 1, n minus 1 plus, okay, n minus 1 cr minus 1 plus n minus 1 cr is equal to nCr. I am seeing this, and according to this, I derive this recursive formula. So if I get one recursive formula, can I try to solve this problem? Yes, I can easily solve this problem. Let's try to code it out, this recursion code. So what I'm saying, there are two base cases. What is the base case? I know if that r is a greater than n, we have to return a 0. Okay, this is the first time. Okay, now what is the second base case? Second base case, if r is equal to 0, that time I also return on to 1. Why? Because I'm looking here. So you can see the 3C0 is a 1, 4C0 is a 1, 5C0 is a 1. Okay. If you clearly look, these 3C3, 4C4 and 5C5 is also 1. So can I say if r is equal to 0 or r is equal to n, the both are same, then you have to return a 0. And if these two conditions are not satisfying, what you are doing? You are just returning that f of n minus 1 r minus 1 plus f of n minus 1 and r. Okay, you are solving this problem. It will give you the answer. So let's try to solve it out. Let's try to code it out. And if once we code, we'll try to submit. If we get any error in the while doing the CAD, we'll try to fix it out on the spot. Okay. So let's see. Okay. So what I am saying, I'll just create a formula. Let's solve, return solve, and it will return n and r. Okay. Now integer solve, have taking one integer and integer r. Okay. If r is greater than n, return a 0. If r is equal to 0 and n is equal to 0, return 1. Okay. This is not a n is equal to 0, n is equal to r. Okay. These two are satisfied. Return solve n minus 1 and r minus 1 plus solve n minus 1 and r, which we already solved. And if try to compile it, I hope it will get accepted. If it won't, we'll try to fix what error we are coming. Okay, so it gets accepted on a test case. If we try to submit it, it won't get accepted. It will give the TLE because the time complexity of our problem is okay. So it gives the TLE. Why? Because the time complexity of this problem is 2 to power n. Okay. Now, if we are looking the problem, we can see there are some repeated cases. Why I am saying this? If you see this, it also come with the 3C1 and 2C0. If I just extend it, what it will have? 3C 1. Okay, this is already here. Okay, and if you try to this, it will become 3c2. Okay, now if you do this, it will again repeat from these test cases. So I am looking a repeated test cases. So can I do the memorization for this test case? Yes, we can. So let's try to memorize it. So integer dp is equal to, I'll do 100 101. Okay, okay, so let's try to memset it. Okay, so dp minus 1 is size of the dp. Let's try. Okay, now what I'm saying, if dp of n and r is not equal to minus 1, return dp of n and r. Okay, why I'm taking 100 and 100, because I have n is equal to 100 and is, so can I take this, I'll just take this as 102 and 102. Why? It won't give the overlay. Okay, just store before return. Okay, let's try to compile it again. Okay, so let's try to submit it. Okay, so it get accepted successfully. Now what is the time complexity of this problem? What is the time complexity of this problem? This is a n squared. Okay, why I'm saying n squared? Because I'm generating a 2D DP. My two variables are changing. Now can we optimize it further? Can you optimize to the n square to the n or something like easily? So, and before the 2 or 3 days ago, we solved the one problem, which is a Pascal triangle. If you know, you solve this problem, okay, already. So what I'm saying, if you are looking that video, which I'm mentioning on the, which I mentioned on, I will, which I will mention on in a description, okay. So let's see what we are doing in that problem, okay. Now what I'm saying, we have to generate an any term. Let me copy that Pascal triangle here, so we'll just easily visualize that problem with that triangle as well. So what I'm saying, okay, so let me just copy it. Okay, so yeah, it gets copied. Let's see. So ignore this. Okay, now suppose I have to calculate this row in a Pascal triangle. So what I'm saying, I know the first term. What is the first term? Which is the 1. Okay, the first row in 1, and I have to calculate a 4c. Okay, this is an 1, 2, 3, and 4. Okay, so I have to calculate a. And this is not a 4. This is a 0, 1, 2, and the third. Okay, so I have to calculate a 3c 0, 3c 1, 3c 2, and 3c 3. Okay, so what I'm saying, I know this term. So can I call the nCr into some x? Why I'm doing x? So I will get nCr. Okay, can I do this? nCr plus 1, because it is increasing from this side. Your r is increasing. So I know the first term of the nCr. I know the first term of the binomial coefficient. I have to calculate the rth term. Okay, rth term I have to calculate. So we calculate that x. How we calculate? Because we know the nCr is equal to, if you try to elaborate it, so nCr is equal to nothing but n factorial upon n minus r factorial, and r factorial is equal to multiplied by x. I have to calculate this x is equal to n factorial upon n minus r plus 1 factorial multiplied by r plus 1 factorial. Okay, now these two are the same, so it will get cancelled, and x is equal to, if I take this in right side, so n minus r factorial upon r factorial. If we try to do this, if I open the bracket, it will become n minus r minus 1 factorial and r plus 1 factorial. Okay, now if we try to solve it further, so let's see what the result will come. So can I say n in n minus r factorial is equal to n minus r minus 1 factorial? Where did it come? Because I know n factorial is equal to n into n minus 1 factorial. Okay, so n minus r factorial is nothing but n minus r minus 1 factorial upon r factorial multiplied by r factorial. Okay, nice. Now n minus r minus 1 factorial. Can I write this as an r plus 1 multiplied by r factorial? Why I'm saying this? Because this formula also satisfies this. Let's try to cancel it out. This is cancelled. This will get cancelled. We left with the n minus r upon r plus 1. Okay, so x is equal to this. So We already solved this problem in that video. If you can check that video as well, so you'll understand clearly. So this is nCr is nothing, nCr multiplied by n minus r and r plus 1 is equal to nc r plus 1. This formula we get from this solution. Okay, now what I am saying, I have to calculate any term n, c and r. Okay, in the previous problem we are calculating this row, we are calculating any x, any nth row. Okay, we know that. So what I am saying, we are going to till nth row to the last of that row. So what I am saying here, if you are looking clearly, so this r is increasing. Okay, if I have to calculate a 5c2, what I am saying, I have to calculate a 5c1 which is 0. Okay, sorry, this is which is 1. Then I'll calculate a 5. Okay, this I calculate a 5c0 which is 0. Okay, I'll calculate a 5c1 which is a 5, and after that I'll just calculate a 5c2 which is a 10. Now how I will calculate, I know the 5c0 is a 1. Okay, now 1 into, I have to calculate a 5c1. Now what I am saying, if I have to calculate a 5c1, what I am saying, 5c0 multiplied by what if I calculate 5 minus 0 and 1. Why 1? R plus 1. We are taking the R plus 1. So 0 plus 1 is 1. So 5c1 1 is 1, and then multiplied by 5, which is called 5. So 5c1 is a 5, which is completely satisfied. Now I have to calculate 5c2. 5c1 multiplied by 5 minus 1 plus 2 is equal to, let's see, 5c1 is 1. What? 5c1 is a 5, which we get here. Now let's try to do 5 minus 1 is a 4. 4 by 2 is a what? Is 2. Now 5 into 2 is 10. So this is 5c2. So this formula is completely work. So what I am saying, if you don't understand this, you'll just watch that video which I mentioned in the description, which I will mention in the description. Let's try to code it out. So I'm just copying this code. Okay, so let's try. I'll just copy this part of the code. I'm not copying the entire part of the code. I'm just copying this part of the code. Okay, so let's try to code it out. Okay, so instead of writing, I just write the I here, I is equal to 0, I less than equal to r and I plus plus. Okay, and okay, now I'll just take an integer previous which is equal to 1. Why 1? Because nc0 is a 1. Okay, so it will start from the 1. So it start from the 0 and previous into I and I plus 1. Okay, now what I'm doing here, you will understand if you watch that video, that previous video, which I will mention for this as well. Okay, let's try to compile it, and if we get compiled successfully, let's try to submit it. Okay, yeah, so yeah, it's compiled successfully. Let's try to submit it. 32 and 31. Okay, so previous, so can I, okay, so this is a problem, I just forget one case as well. So can I do the r is equal to minimum of r and n minus r? We can do this as well. If you know the combinatorics, if you know the binary coefficient rule, you can easily do this probability and something. You have same topic. Okay, so let's try to compile it. Okay, so this is an input. So what is the output we are getting? 32 and 31. Na? 32 and 31. Okay, let's try to do this. Okay, and yeah, so this get compiled successfully. Let's try to submit it again, and let's discuss what is the time complexity of this program. So if it get accepted, we will discuss the time complexity of this program as well. Okay, so it is giving the error for this. Why? Because we are calculating the very difficult task where we are doing multiple multiplications, and it will going to the integer overflow. Yeah, so let's do the same thing with the 32 and 12. So this all just giving the integer overflow. So I'll do this long as in previous, and by passing this, I'll just do this in integer form. Okay, why I'm doing this? Because it will go to the integer. It is giving me the integer overflow. So I'm just doing the long for the safer side. Okay, because we are doing the multiplication. And okay, so now if I go and try to submit it, Hope it will get accepted. If we get any error, we'll try to fix it out. Okay. Yeah. So yes, it get accepted successfully. And what is the time complexity of this? The time complexity of big of R. Okay. Yes. So now the question is why I am doing this. That why I am changing the R with the minimum value. R is equal to R and minimum. Okay. So why I am doing this minimum R and n minus R. So if you look clearly, that 4, if you see this, the 5C 0. Okay, if you see the 5C1 is a 5. Okay, this is a clear observation you are looking here. If you look the Pascal triangle, okay. So if you look the clear observation, what is the 5C0? The 5C0 is 5. Okay, no, 5C1 is a 5. Okay, correct. Okay, forget about this. In a particular period of time, it will repeating. Okay, means 5C1, 5C0, 5C1, and 5C2 is same as 5C3, 5C4, and 5C5. Okay, you can see this. This is similar. So if I get a 5C4, if I do this R, 5C 5 minus 4, which is 5C1. Now 5C4 and 5C1 are same. Yes, both are same. So that's why I'm just updating this, because if you do that biggest multiplication like a 32 and 31, it is giving me the wrong answer. Okay, 32 and 31, that give the integer overflow, and that doing the wrong multiplication. Okay, so that's why because we are doing division and multiplication at the same time. So there might be a 90% chance it will give the wrong answer. So that's why I'm just updating the R. Okay, so this is for today problem statement. So let's meet tomorrow with a new problem. Bye for today.